California's coastline is vanishing, not eroding over decades, not retreating over years, vanishing. Right now, on February 27th, 2026, entire sections of California's most iconic sea cliffs are dropping into the Pacific Ocean in seconds, taking homes, highways, and everything built on top of them straight down into the churning water below. Scientists who have studied these formations for their entire careers are standing at the edge of collapse zones, staring at readings on their instruments and asking a question that should never have to be asked. How did this happen? February 27th, 2026, 5:43 in the morning, Pacific Standard Time. A California Geological Survey monitoring station positioned along the bluff line north of Pacifica detects ground movement readings that immediately trigger automated emergency alerts across 3 separate monitoring networks. The numbers appearing on screens at the California Department of Conservation headquarters in Sacramento are not supposed to be possible. Engineers reviewing the data in real time reach for their phones before the analysis is even complete. By 5:51, the first collapse occurs. A 240-foot section of coastal bluff north of Pacifica drops directly into the Pacific Ocean. Not gradually, not in stages. In one single catastrophic movement lasting less than 20 seconds. Residents describe the sound as a thunderclap combined with a freight train. The ground simply ceases to exist. 3 homes that were standing on stable certified ground the night before disappear with it. By 6:17, the second failure strikes further south near Daly City. A section of bluff measuring 180 feet wide shears away from the coastline with a sound witnesses describe as a crack of lightning that never stopped. A section of the coastal trail that thousands of residents walk every single morning is gone. The trail does not end. It simply stops at open air above a 70-foot drop to broken rock and churning surf. Emergency protocols activate across San Mateo County at 6:30. But the collapses do not wait for emergency protocols. A third failure hits near Moss Beach at 6:44, a fourth near Half Moon Bay at 7:02. By 7:30 in the morning, California Highway 1 shows stress fractures visible from aerial surveillance across 6 separate locations. The California Department of Transportation deploys emergency inspection teams, but inspection teams cannot stop what is already in motion. By 8 o'clock, the scope of the catastrophe becomes undeniable. 41 miles of California coastline are closed to all access. Emergency managers describe arriving at locations they have driven past their entire lives and finding nothing where there was once solid ground. The bluffs that define this coastline, that appeared in 10,000 photographs and 100 years of postcards, are gone. The numbers arriving at emergency coordination centers, staggering. 17 confirmed collapse events along a 41-mile corridor. 11 residential structures lost or critically compromised. 432 residents under immediate mandatory evacuation orders. And the ground is still moving. To understand what is happening to California's coastline on February 27, 2026, you have to understand what that coastline actually is. These are not rocky mountain faces built from granite and bedrock. The sea cliffs running along San Mateo County, Santa Cruz County, and the Marin Headlands are composed primarily of soft sedimentary formations, mudstone, sandstone. Ancient marine deposits compressed over millions of years into formations that look solid and permanent from above, but are fundamentally vulnerable to the forces now attacking them from every direction simultaneously. The base of these cliffs takes constant assault from Pacific wave action. Every wave that strikes the base of a coastal bluff removes material. Every storm surge accelerates that removal. The cliff above loses its foundation support in increments so small they are invisible to the human eye, until they are not. But wave erosion alone does not explain what is happening today. The saturated soil crisis changes everything. The atmospheric rivers that battered California through January and February of 2026 delivered rainfall totals that shattered records in place since 1880. The soil comprising the upper sections of these coastal bluffs absorbed water until absorption became impossible. Then, it absorbed more. Saturation levels across the coastal bluff formations north and south of San Francisco now measure 400% above stable threshold capacity. 400%. That number means the soil is not functioning as soil. It is functioning as liquid, held in the shape of soil by nothing more than surface tension and the memory of its former structure. The moment any additional stress disturbs that fragile equilibrium, the entire mass moves. And there is another factor that makes this event uniquely terrifying. The underground water table along California's central coast has been rising for 3 consecutive years. Groundwater that would normally drain eastward through permeable layers has been blocked by clay deposits swollen with excess moisture. That trapped water has been accumulating directly beneath the bluff formations, building pressure, saturating the base from below while atmospheric rivers saturate it from above. The bluffs were caught in a vice: pressure from the top, pressure from the bottom, wave assault from the front. And after months of that combined assault, the formations that appeared solid and permanent and eternal did what physics always promised they would eventually do. They let go. At United States Geological Survey offices in Menlo Park, geologists and coastal scientists spent the hours before dawn on February 27th staring at data that had been building toward this moment for weeks. Dr. Patricia Huang, lead coastal geologist at the USGS Pacific Coastal and Marine Science Center, had been tracking bluff saturation indices along the San Mateo County coastline since early January. The numbers had been climbing steadily. By February 20th, 3 monitoring stations were already registering readings she describes as deeply alarming. By February 24th, 2 additional stations joined them. The instruments were not measuring erosion, they were measuring instability. Ground deformation sensors positioned along the bluff line detected lateral movement of 0.8 inches per day across a 12-mile section of coastline. That rate is not erosion. That is mass movement. An entire geological formation shifting toward the ocean under the weight of water it can no longer support. Pore water pressure readings delivered the most terrifying data of all. Pore water pressure measures the force of water trapped within the spaces between soil and rock particles. When pore water pressure exceeds a critical threshold, the internal friction holding geological formations together collapses entirely. The readings arriving from coastal monitoring stations in the 72 hours before the February 27th collapses showed pore water pressure values that exceeded every threshold in the database by a factor of 3. Dr. James Vasquez, at University of California, Santa Cruz, one of the nation's leading experts in coastal bluff dynamics, reviewed the pre-collapse data during an emergency briefing on the morning of February 27th. His conclusion was as stark as it was devastating. The formations were not failing because of any single cause. They were failing because every stress factor that coastal geologists study in isolation had arrived simultaneously: wave energy, groundwater pressure, surface saturation, and reduced cohesion in the underlying mudstone layers. Scientists had modeled scenarios where these factors converged. They had placed those scenarios in the category of extreme outlier events unlikely to materialize before the middle of this century. They materialized on February 27, 2026. And here is what has scientists in complete panic. The monitoring stations are not showing stabilization. They are showing continued movement. The bluff sections that have not yet failed are displaying the same pore water pressure signatures that preceded the sections that already have. The geological conditions driving these collapses have not resolved. They are ongoing. What happened this morning may not be the peak of this event. It may be the beginning. David and Karen Olson moved to their Pacifica Bluff-top home in 1994, 32 years of sunsets over the Pacific. They watched that coastline from their back deck for 32 years. They raised 2 children in that house. Their youngest daughter learned to walk in that kitchen. At 5:51 in the morning on February 27th, 2026, their home drops into the Pacific Ocean. They are not inside when it happens. A mandatory precautionary evacuation notice issued the previous evening, based on preliminary monitoring data, sent them to a motel in Daly City. David Olson watches the collapse on his phone, live-streamed from a neighbor's security camera. He watches the house he has lived in for 3 decades simply vanish in less than 30 seconds. He tells emergency responders afterward that he cannot find words for what he is feeling. Nothing in his life prepared him for watching his home fall into the ocean on a mobile phone screen while sitting in a motel parking lot. He is one of 432 people under mandatory evacuation orders by 8 o'clock in the morning. He is one of thousands who will never return to the homes they left behind. Margaret Solano is 67 years old and has lived on the coast south of Daly City her entire life. She was born in the house her parents built. She does not leave when the evacuation notice arrives. Emergency responders find her standing in her backyard at 7:15 in the morning, watching the edge of her property. A crack in the ground runs parallel to the bluff edge, 14 feet from where she is standing. The crack is 4 inches wide. It was not there yesterday. Responders physically guide her to an evacuation vehicle. She keeps looking back. The emergency shelters opening across San Mateo and Santa Cruz counties fill within hours. People arrive with whatever they grabbed in the dark: medications, documents, pets, photographs. The things that cannot be replaced. They sit in evacuation centers and stare at nothing, processing a reality that has no roadmap, no precedent, and no clear resolution. The collapsing coastline is not just taking homes. It is taking the systems that hold modern life together. Highway 1, the iconic coastal road that has connected California communities since 1937, shows critical structural compromise at 6 separate locations along the affected corridor by 9 o'clock on the morning of February 27th. California Department of Transportation engineers arriving at inspection sites describe conditions they have no existing protocol to address. The road surface is intact, but the ground beneath it has shifted laterally toward the ocean by margins that make the roadway structurally unsound without any visible surface damage. This is the hidden danger that makes this crisis uniquely lethal. The ground looks normal. The road looks drivable, but the formation supporting both has moved beyond the threshold of safe loading capacity. A vehicle on that surface is driving on a shelf that is preparing to let go. Highway 1 closes completely from Pacifica to Santa Cruz by 10:30 in the morning. 47,000 daily vehicle trips reroute through inland corridors designed to handle a fraction of that volume. Emergency supply chains to coastal communities fracture immediately. Pacific Gas and Electric reports transmission infrastructure compromise at 4 coastal locations by noon. A major gas distribution line running parallel to the bluff edge near Moss Beach requires emergency shutdown after ground movement displaces the line beyond safe operational parameters. 42,000 customers lose service. Utility engineers describe attempting to assess infrastructure in terrain that is actively moving beneath them. Telecommunications infrastructure suffers cascading failures, as fiber conduits buried in the bluff formations are severed by ground movement. Cell towers, positioned along the coastal ridge, lose structural integrity assessments across a 12-mile stretch. Emergency managers lose reliable communications across a section of coastline where reliable communications are most critically needed. Water treatment and distribution infrastructure faces inspection across 130 miles of coastal service territory. Pipelines built on the assumption of geological stability are now running through formations that have demonstrated they are not stable at all. The question that is driving emergency managers in Sacramento and Washington toward crisis mode on February 27, 2026, is not about what has already collapsed. It is about what has not collapsed yet. USGS coastal monitoring networks extend from the Oregon border to the Mexican border. The same atmospheric river systems that saturated the San Mateo County bluffs have been depositing moisture across the entire California coastal zone for 6 consecutive weeks. The same groundwater table rise affecting the formations north of Half Moon Bay is measurable in coastal formations from Point Arena in Mendocino County all the way south to Point Conception in Santa Barbara County. The bluff formations along this entire corridor share the same fundamental geological composition: sedimentary mudstone and sandstone deposits. The same vulnerabilities, the same failure mechanisms. As of February 27th, the same saturation conditions that preceded the collapses in San Mateo County were present across the corridor. Dr. Wang at the USGS issued a public statement at 11:45 in the morning that sent coastal emergency managers across the state into immediate action. Current monitoring data indicates elevated collapse risk extending across approximately 230 miles of California's central and northern coastline. Precautionary evacuation assessments are recommended for residential and commercial structures within 200 feet of the bluff edge across the entire affected corridor. The number of residential structures within the risk corridor runs into the thousands. The assessed property value at risk exceeds $80 billion. The human displacement potential, if conditions continue deteriorating, represents the largest non-hurricane coastal evacuation in American history. Emergency planners in Sonoma County began precautionary assessments of the Bodega Bay bluff formations. Mendocino County activated monitoring protocols for coastal communities from Fort Bragg to Point Arena. Santa Cruz County expanded its evacuation orders southward. Monterey County placed the Carmel and Big Sur coastal bluffs under immediate elevated risk classification. The collapses that began north of Pacifica at 5:51 in the morning have opened a question that nobody has an answer to yet. Where does this stop? At emergency scientific sessions convened across California through the afternoon of February 27th, researchers were forced to confront a conclusion they had been approaching for years and could no longer defer. This was not a surprise. This was a prediction, and the prediction was ignored. California Geological Survey reports published in 2022 and 2024 both identified the state's coastal bluff formations as critically vulnerable to the convergence of conditions now driving the February 27th collapses. Sea level rise was increasing hydrostatic pressure at the base of coastal formations. Atmospheric river events were delivering rainfall totals that exceeded the drainage capacity of coastal soils. Groundwater management systems designed for 20th century precipitation patterns were failing to handle 21st century moisture volumes. Both reports recommended accelerated monitoring, expanded buffer zone regulations, and precautionary acquisition of the most at-risk coastal properties. The recommendations sat in planning department files while the conditions they warned about continued developing. Sea level along the California Central Coast has risen 3.4 inches since 2000. That number sounds modest. In the context of coastal bluff stability, it is not modest at all. 3.4 inches of additional sea level places wave energy at elevations that previously only saw wave assault during major storm events. The base of these formations is now being attacked at levels that the geology was never subjected to during the 10,000 years of relative sea level stability that preceded the industrial era. The atmospheric river events of January and February 2026 represent conditions that climate models projected would not become regular occurrences until 2050 or later. They are occurring now. The same acceleration that brought unprecedented storm intensity to Big Sur in 2024 has brought unprecedented bluff saturation to the entire Central Coast in 2026. Climate scientists reviewing the data describe a coastal system that is being asked to absorb stresses that compound faster than the geological formations can adapt. The bluffs do not have the capacity to adjust. They have only two responses available to them: hold or collapse. On February 27, 2026, they collapsed. And the conditions that drove them to collapse are not temporary weather events that will pass and allow recovery. They are structural features of a climate system that has shifted into a new operating regime. The atmospheric rivers will come again. The groundwater tables will remain elevated. the sea level will continue rising. Every year that passes, the forces attacking California's coastal formations grow stronger. Every year that passes, the formations themselves become more saturated, more compromised, and more vulnerable to the next event. Engineers and geologists working the collapse sites on February 27th are already having conversations that no one wants to have, publicly, about which sections of coastal bluff can realistically be stabilized and which cannot, about which communities built on those formations have a viable long-term future in their current locations and which do not, about whether the investment required to maintain human infrastructure on California's central coast is sustainable against the forces that are now demonstrably capable of removing that infrastructure in seconds. These are not comfortable conversations. They are necessary ones. 1 week from now, the immediate emergency response along California's collapsed coastline will still be ongoing. The displaced residents will still be in evacuation shelters. The closed sections of Highway 1 will still be closed. The monitoring stations will still be recording movement in formations that have not yet failed, but are showing every indication that they intend to. The questions raised by February 27, 2026, will not have answers in a week. Many of them will not have answers in a year. Can the communities built along California's central coastal bluffs be protected? Can the infrastructure serving those communities be maintained on ground that has demonstrated its willingness to move without warning? Can the insurance industry continue to underwrite properties in geological risk zones that are now provably active? Can individual families be expected to rebuild lives on coastlines that may collapse again before the rebuilding is complete? The California coast has always carried risk. The people who built their lives on these bluffs understood on some level that the ocean was always there, always working, always taking back what it considered its own. What has changed is the speed. What has changed is the scale. What has changed is the convergence of forces that previously arrived one at a time and now arrive together, simultaneously, without the intervals of recovery that allowed the coast to absorb one stress before the next one came. The formations that dropped into the Pacific on February 27th had stood for thousands of years. They stood through storms and droughts and earthquakes and the slow, patient pressure of 10,000 tides. They did not fail because they were weak. They failed because the world they were built in no longer exists. The climate that shaped them and that they were stable within has reorganized itself into something they were never designed to survive. The coast that California knew throughout the 20th century is not the coast that California will have in the 21st. The bluffs are telling that story now. They are telling it in the only language geology knows, not in reports or projections, or warnings issued and filed away. In the sound of 200 feet of coastline dropping into the ocean in 20 seconds on a Thursday morning in February, while the instruments record every moment of it and scientists stare at the data and ask the question that has no comfortable answer. How did this happen? The answer is that it happened the same way all slow catastrophes happen, gradually, then all at once.